Okay, then we'll start. Then I'll share my screen first. So, good evening, everyone. My name is Vaibhav Gupta, and I am a PMRF scholar at IIT Madras. So, I'll be teaching you mechanics of material. Basically, I'll be helping you in solving the uh, example problems, which will help you in getting the more clear view of the course. And I'll be explaining you some concepts which will help you in the course related stuffs. So, this is our first lecture for today's session. So, what I'll be doing in my class is like initially for like a few minutes I'll be telling you about the week's concept, like whatever has covered in the week related thing. Like for example, today I'll be covering few topics of week one, and then I'll start with some problems I'll solve. If you have doubt anywhere, you can stop me any point. And in the last, we'll have a discussion thing. So if you have doubts related in concepts or related in assignments, you can ask. So we'll start. So this session will be known as a live session. So this is live session one. Every week we'll meet. We'll be meeting on Monday at 6 to 8 o'clock, and we'll be covering all the concepts covered in the week. So in basically in week one, what is taught it by the sir is like in previous years or in like in plus two or BTech first year, you will be studied about engineering mechanics. So in engineering mechanics, you have dealt with mechanics of rigid bodies. Whereas in this course, you will be dealing with mechanics of deformable bodies. So first of all, question arises: what is the difference between rigid bodies and deformable bodies? So as the name suggests, rigid bodies are those bodies in which the 2 points are not moved apart. Like the body is said to be rigid if the distance between any 2 points in the body doesn't change due to the application of a force. Whereas for deformable bodies, if the distance between 2 points is changing due to the application of force, it's known as deformable bodies. Distance between 2 points are not changing due to application of force. And here distance between 2 points will change due to application of force. So next terms arise, like why we assume a body to be a deformable body. Why don't we use only rigid bodies and we all apply the concepts involved in engineering mechanics? So in the class also sir covered the basic example of this truss problem, where sir has explained like this is a truss of member ABC and a load T has been applied. So if you go through the lecture, sir will be using two equilibrium equation like sigma fx equal to 0. If we assume the axis like this, x and y. One second. Yeah. And second equilibrium equation, sir will be using this sigma f equal to 0. If you satisfy these both equations, you will be getting two equations and you are having two unknowns, FAB and FBC. So now you have two equations and two unknowns. So you can solve the problem. While if I add one more member here along with AB and BC, I add one more member BD, which is 90 degree towards the point B, and apply same load P. Now you have only two equilibrium equations, but this time you will be having three unknowns. That is FAB, FBD, and FBC. So you cannot solve three unknowns with the help of two equations. So you require one more equation. That's where we have to assume the body to be a deformable body. So there comes the picture of deformable bodies. Hence, we are studying mechanics of materials. I hope you have understood this point. If you have any doubt, you can ask at the end of the lecture, or now you can ask. So moving ahead. So basically, in this course, we'll be dealing with four basic concepts of equation. Equations to be used in this course. So basically, we have one term force. One we have displacement. They both are indirectly related. We cannot relate force and displacement directly. So why we don't relate force and displacement directly? The reason is if we assume a bar of length L and area of cross section A, and if you apply a force P, so you will get a displacement of some delta. Suppose after application of force P, the bar becomes like this. Now if we say the bar is made up of steel, first bar, and second bar is made up of rubber, will delta be same? The answer is no. That's why we need two more quantities which will relate displacement and force. So hence we need one term as strain, where we need strain displacement relationship. And one more we need stress, to have stress and force relation. The inside knowledge of all these things you will be getting in the subsequent lectures when you go ahead. So to have a brief introduction, what is a strain? So suppose if you consider the same bar and if you apply a P, it deflects by a so if you assume a bar and we apply a force P, it will deflect a delta thing. But if you can see, this bar is also shortening here. It's shortening in delta y, and this suppose we say delta x. So strain is nothing but it will relate displacement in all the directions. So strain will help you in relating the displacement after applying a force P in all the directions. Now what is stress? So stress is nothing but force upon area, which you have studied. Though the definition is not applicable in many of the cases, but you will be able to you will be learning the new definition of stress when you go into the subsequent lectures. But for as of now, we'll say like stress is nothing but force upon area. There is one more relation which relates stress and strain. This is nothing but called as constitutive relation. It's nothing but relating stress with Young's modulus. You have studied in first year in engineering mechanics. It's having direct relationship like Buck modulus, Young's modulus, Shear modulus. It's having more application If when we go ahead, we'll see what are the relations. Now you can see here I have related only in one direction, whereas I have here we are related in both the ways. So the meaning is the strain can also be related to displacement with the help of compatibility equations. This is known as compatibility equation, and the strain is related to displacement. So why we need compatibility condition? In engineering mechanics, we don't allow separation of two surfaces to form a void in between, and also we don't allow interpretation of two surfaces, interpenetration of two surfaces. Like the two surfaces cannot bulge in or cannot separate out. So to take care of all these things, we need to relate strain with the displacement, and how we will relate with the help of compatibility conditions. As of now, you don't have to worry of all these words. In subsequent weeks, you will be getting to know each and everything step by step. But overall, as an overview of this course, this all four things we will be requiring to get the knowledge of this course. Okay. So next of all, in the first week, the major thing that the professor has carried out is the term notations, which is very important going to the future of mechanics in structural engineering, because without these notations, you won't be carrying out your calculations in a very systematic manner. So suppose if we first define a matrix, how we will define like this? Suppose 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is how we write a matrix in this form. So in now in this course we'll be using the notation of matrix A as Aij, where I will be telling us number of rows and J will be signifying number of columns. So suppose if I have to say what this 9 represents. 9 is nothing but matrix A in third row, third column. Okay. Similarly, we can write this matrix in this manner. A11, first row, first column. First row, second column. A13, first row, third column. Second row, first column. A22, second row, second column. A23, second row, third column. A31, third row, first column. A32, third row, second column. And A33, third row, third column. So this is one of the notations that you have to be learn. You have to learn these things. Okay. Similarly, vector. In the lecture, you have seen that many examples have been given to denote a vector like this. What is a vector? So, in the lecture, sir has given 5 options to know what is a vector. We can write vector like this. We can write vector like this or this. So, which of the following is correct? So, for our mechanics point of view, we will be saying that this is the correct way of representation because it signifies the geometrical object. Whereas in mathematical terms, all are correct. And in terms of notation, we'll define vector as this in mathematics. All are same. So now next comes the requirements, like what you all know going forward in this course. You must be knowing like algebraic calculations, vector multiplications, dot product, cross product, matrix multiplication, matrix additions. I'll be solving some examples using these things to get you the better understanding of these things. So going ahead, So what is a dot product? Suppose we have two vectors. This is a vector, this is a v vector, and this is an angle theta. So the projection of b on a will be equal to, what is this distance? It's a projection of b vector on a. It's nothing but cos theta. So how will write? A dot b will be equal to a b cos theta. This is nothing but a dot product. This is known as norm of vector A, and this is norm of vector B. If anyone is having any doubt, you can stop me anywhere. We'll discuss and then we'll proceed further. One second. Yes. Now going ahead. Second is cross product. In this course, we'll be denoting cross product as this indication. Okay. This means cross product of vector A and vector B. So what is cross product in terms of, suppose this is a C vector. So cross product is nothing but the area of parallelogram with vector A and B as its side. Okay. Suppose this is a B vector, this is A vector. So these are the sides of parallelogram. So C is nothing but the perpendicular of this plane. This is a C vector in terms of significance. So this is nothing but cross product. Now in mechanics, while using dot product, we'll be using, and cross product, we'll be using two symbols. First is delta ij, and second is epsilon ijk. This is known as Kronecker delta. Okay. So it's nothing but when A dotted with B, it will be AB when A dotted with B, it will be AI BJ delta IJ. Okay. So suppose for this thing, it will be equal to 0 when I is not equal to j. Okay. And it will be equal to 1 when I is always equal to j. So suppose delta 1 1 is equal to delta 2 2 is equal to delta 3 3 is equal to 1. Whereas delta 1 2 equal to delta 2 1 equal to delta 3 1 delta 1 3 equal to delta 2 3 delta 3 2 is equal to 0. We'll see an example. Suppose two vectors in which A vector is equal to I cap plus 2j cap plus 3k cap, and B vector we write as 2i cap plus 4j cap plus 6k cap. So what is A dotted with B? So it's like AI BJ delta IJ. Okay, where I belongs to 1 to 3. and j belongs to 1, 2, 3 because 3 terms are there in each one. Okay, so we'll write first taking I as 1 and j as 1. A1, B1, delta 1, 1. Okay, plus A2, B1, delta 1, 2. Sorry, delta 2, 1. Plus A3, B1, delta 3, 1. Now plus A2, sorry, A1, B2, delta 1, 2 plus A1, B2, delta A2, B2, delta 2, 2 plus A3, B2, delta 3, 2 plus delta A1, B3, delta 1, 3 plus A2, B3, delta 2, 3 plus A3, B3, delta 3, 3. Now you can see this term goes to 0 because delta 2, 1 is 0. This 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 is 0. Okay. So now we are left with A1, B1, delta 1, 1 plus A2, B2, delta 2, 2 and plus A3, B3, delta 3, 3. Now you are seeing is complex things because the example is simple. But when it comes to a different problems with more mathematical concepts and difficult to understand, these all notations will work out very good. Okay, so learning these notations and to proceed all the examples with these notations are very essential for you to learn in a systematic manner. So what is A1? A1 is nothing but 1, B1 is 2, delta 1, 1 is 1. Plus what is A2? A2 is 2, B2 is 4, delta 2, 2 is 1. What is A3 is 3, B3 is 6, delta 3, 3 is 1. This is nothing but 2 plus 6 plus 8 plus 18 is 28. So this is the answer. Okay. Similarly with the cross product, so A cross B, we'll use the same example. A as I cap plus 2j cap plus 3k cap and B as 2i cap, 4j cap and 6k cap. So it's nothing but ai cap plus bj cap epsilon ijk and k. Okay, n is nothing but a unit vector. So what is epsilon ijk? It will be equal to 0 when I will be equal to j or j equal to k or k is equal to I, or it will be equal to 1 when ijk goes in a clockwise direction. Like it's like 1, 2, 3. So 1, 2, 3, 1, 1, ijk 1, jki 1, kij 1, and minus 1 when it takes a loop of anti-clockwise direction. We'll see with the help of examples. You will be able to know. This nk is nothing but a unit direction vector. Unit vector. So suppose we have example A as I cap plus 2j cap plus 3k cap, B as 2i cap plus 4j cap plus 6a cap. We'll take this example. So we'll write one by one. What is A cross B? It is ai cap, bj cap, epsilon ijk and eta k. Okay. So we'll write it's one by one. It's A1, B1, epsilon 1, 1, 1, eta 1 plus A1, B2, epsilon 1, 2, 1, eta 1 plus A1, B3, epsilon 1, 3, 1, eta 1 plus so on. Okay. We'll see with what these three things are. See here epsilon 1, 1, 1. See I is equal to j and also is equal to k. So this nothing but becomes 0. Okay. In second, it's I is equal to k. So again it becomes 0. In third also, I is equal to k. It becomes 0. So suppose we move forward in this example, since all r becomes 0, I'll show you more terms. Suppose we'll take a as 2. A2 B1 epsilon 211 N1 plus A2 B2 epsilon 221 N1 plus A2 B3 epsilon 231 M1. Hello.
यस सर.
Yeah, any doubt?
यस सर, ये ऊपर का एक स्टेप नहीं समझ में आया, कैसे ये तीनों जीरो हो गए?
हाँ, I'll explain you.
Okay, sir.
So in this above equation, I'll say epsilon ijk. So it will be equal to 0 when I is equal to j, or j is equal to k, or k is equal to I. Okay. Now in this first expression, it's epsilon 111. Here in this case, I is equal to 1, j is equal to 1, k is equal to 1. Okay. So I is equal to j and j is also equal to k. All three are equal.
Yes, sir.
So it becomes 0. You got it?
Yes, sir.
Similarly, in second case, it's epsilon 121. Here I is equal to k. Both our values are 1. So epsilon 121 is 0. Similarly, in third case. Okay. Now moving forward. Here epsilon 211. Here j is equal to k. So again this epsilon goes to 0. Here again I is equal to j. So epsilon again goes to 0. But in this thing, it is A2 B3 epsilon 231 eta 1. So suppose if I denote I as 1, j as 2, k as 3. So 231 is what? It's clockwise direction or anti-clockwise direction? Can you answer?
Anti-clockwise.
231 is clockwise direction. See here.
Oh, sorry, sir.
So here epsilon will take value 1. Okay. So it will become A2 B3. This value is 1. Eta 1 is nothing but I cap. Eta 2 is j cap and eta 3 is k cap. It's a unit vector. You can denote. Okay. So when you write all the terms, you will get here as A2 B3 minus B2 A3 eta 1 minus A1 B3 minus B1 A3 eta 2 plus A1 B2 minus B1 A2 eta 3. If you have studied in your mathematics, it's nothing but a determinant. If you see like that, ijk A1 A2 A3 B1 B2 B3. How will you solve this determinant? It is nothing but this cross multiplication of I cap. Understood?
Yes, sir.
But in terms of notation, it should be identified like this only. Like A cross B should be written like that only always. AI Bj epsilon ijk eta k. Okay. See, in simpler examples, it's very easy to understand in numeric ways. But when problems become complex, it's better to go with notations. This is what the fundamental of this lecture is. Okay. So now you are familiar with dot product with Kronecker delta here. What is Kronecker delta? This delta ij. It will be equal to 0 when I is not equal to j. It will be equal to 1 when I is equal to j. Similarly, this symbol is known as permutation symbol. So in the tutorial or in the assignment also, you will be dealing with these two symbols. Okay. So just whatever is given in the paper, in your tutorial sheets or in the assignment sheet, just put the value of I and j. I belongs to 1 2 3. Put the value of I as 1 first time, j 1 2 3. Then put I as 2, j 1 2 3. Put I 3, j 1 2 3, and you will find the answer as per this notation. Got it? I will solve one more example for you to better understanding at the end of this lecture. So first I'll explain you the concepts. So second thing, now in this thing, suppose this is a matrix, this is a vector. Okay. Now if we multiply a matrix with a vector, what we will get? We will get a vector B. Okay. This is always true. Okay. Suppose matrix is having a size of 3 by 3. Vector is having a size of 3 by 1. So what will be the size of vector B? It will be always 3 by 1. Okay. But in terms of notation, how will you represent? A is nothing but Aij. Okay. Matrix representation. Vector you will represent as Aj. These symbols you can use whatever you choose. Okay. It can be B, it can be C, it can be D. But what is followed is like IJK. This type of symbols are followed in generally. And you will get a B vector of Bj. Okay. Now, how we are getting, I'll tell you. Suppose A is 1, 2, 3, 4, 5, 6, 7, 8, 9. And A is a vector of 1, 2, and 3. So, how will you multiply the matrix? The first row will multiply with the first column and will add. That is what matrix multiplication is: 1 cross 1 plus 2 cross 2 plus 3 cross 3. Second is 4 cross 1 plus 5 cross 2 plus 6 cross 3. Last is 7 cross 1 plus 8 cross 2 plus 9 cross 3. So what is this? This becomes 1 plus 4 plus 9, 14. 4 plus 10 plus 18, 32. 7 plus 16, 23 plus 27, 50. Okay. This is also a size of 3 into 1. Till now clear?
Yes, sir.
Okay. Now I'll move one step forward. See, here I am writing for notations. Okay. Suppose you have to cut it short also, this thing. Okay. So this is nothing but its value from I1 to 3. You are calculating. Okay. When I goes 1 to 3. But simply, when we are writing like this, it has some meaning. Okay. I'll show you. We have two type of indexes. What do you mean by indexes? This Aij, this I and J are nothing but index, where I is a row index. Okay, and J is column index. This both termed as index. Okay. Now we have two type of index. One is free index and second is dummy index. Okay. So suppose if I write AII is equal to some random number, constant number 4. What is the meaning of this? So the meaning is, if same index I is repeating twice on same side, it's on left hand side. Here AII is on left hand side. Okay, and 2 times I is repeating. So it means it is known as a dummy index. And when the index is dummy, you have to use it like this. This is the actual meaning of dummy index. I has a value of 1, 2, 3. So what you will write? You will write A11 plus A22 plus A33 is equal to 4. Okay, got it? Simpler version is AII is equal to 4. You got it? What is dummy index? Suppose if I write AII is equal to CI. This is wrong. Our index cannot repeat more than twice. Okay. This thing is wrong. It has to be repeated twice only. So suppose if it repeats like this, Aij is equal to Bj. One second. Free dummy index you understood, everyone?
Yes, sir.
Okay. So now we'll go with free index. What is free index? So suppose if it is written like this, see some else will take. Suppose it is written like Bj. Here J is twice repeated. Okay, but it is not on the same side. Okay, so here you don't have to sum J1 equal to 3. Okay, you will not sum. It will be like whatever the value of J is given in the question, like if J belongs to 1 only, you will give only for one value. If it's written for J equal to 1 to 3, 1, 2, 3, you will take this summation for, you will write for 3 values of J. You will not have a summation mark. Got it? J equal to 1 to 3, Aij. You cannot do. Okay? Whereas if it is written like Ajj, then you have to perform summation of J equal to 1 to 3. It should be understood well before. So when you are going for matrices with notation, you have to first check whether it consists of dummy index or it consists of free index. So if the matrix has a dummy index, you have to automatically sum that matrix from 1 to 3 for that particular index which is dummy. Understood?
Yes.
So for this I'll solve one example for you, that how to check whether the index is dummy or free. One second. So suppose you have this example. Example 1. AI Bj to Ci Dk minus Ek. Okay. First of all, is this expression is valid or not? first of all, we'll check this thing. See, in left hand side, how many index we have? I and J. Two index we have. Okay. Whereas in right hand side we have I and K. Two indexes. Okay. Now see, a new index cannot come if we are not multiplying. Okay. Like here in left hand side we have two indexes I and J. So the resultant should have two index. In any form they can be. But it should be that two index only. We cannot introduce a new index. Suppose if I multiply a matrix 2 comma 3 with B matrix as 3 comma 4. Now here we have three indexes. I is equal to 2, J is equal to 3 and K is equal to 4. So what we will get? A C matrix of 2 into 4. We are getting as index as I and K. We are not getting an extra index as whatever P. You are getting my point? So in left hand side, whatever the indices are present, it should be present in the right hand side. So since in this question K is present on the right hand side, which is not there in the left hand side, so this expression is invalid. Got it? The expression is not correct. Any question in this problem? Understood? Okay. I'll do another problem. Now I'll say same example with different thing. Tell this expression is valid or not?
Valid, sir.
Valid. Okay. Because those indices which are present in the left is there in the right. But there is this is first condition. Second condition we have to check the indices to be dummy and free. Okay. Tell me. If we open this equation, it will become Ci dj minus Ci fj. Okay. So what is I and what is j? They are dummy index or free index?
Sir, free index.
Yes, free index. Correct. So you have not got the point of free index and dummy index. I will tell you one example of. So in free index, you will not sum this thing, okay? If it's a dummy index, you would have summed it. Okay. So now this expression will be only be used when we have given some values of ij and ij like this. If I is equal to 1, 2, 3 or 1, 2, whatever. Okay. Now suppose I will give you one more example. Ni is equal to 1. Is this expression valid? This I is nothing but the identity matrix.
Yes, sir.
So this is what index it is. This is a valid index. So what index this I is? Free index or dummy index?
Sir, free index.
No, dummy. See, I is repeating twice on the same side.
Yes, sir.
So what it is?
Dummy. Sorry, sir.
Dummy index. It's okay. So now you have to sum I from 1 to 3 automatically. So it's nothing but n1 square plus n2 square plus n3 square is equal to 1. The expression is originally like this, but we have cut short it to like this. You got the point? So now you must be knowing like what is free index and what is dummy index. What is a valid expression, what is not a valid expression. I will give you one more example. This is a valid or not? Okay, I'll tell them. Anyone wants to answer? Shiva? Okay, I'll say. See, here two indexes are there and J is repeating twice and on the same side. So J is a dummy index. Okay. Where I is I, it can take any value which is given in the question, like 1, 2, 3. But J, we have to sum J as 1 to 3. So it's like AI B1 C1 plus AI B2 C2 plus AI B3 C3 is equal to 5. This is what the expression is actually. Okay. Anna got it?
Yes, sir. Sir, we put any value.
Whatever given in the question.
Okay.
They mentioned I as some value in the question then.
Sir, one minute. Please note this question.
So, if it's a dummy index, they will not provide the value. You have to understood by your own that it should be a summation of 1 to 3. Okay. So first you have to check whether the expression is valid or not. Second, you have to check which index is dummy. Third, you have to check which index is free. Okay. This type of questions are there in the tutorial on your assignment also. So I'll move ahead.
Yes, sir.
Okay. One more example I will take. It's a typical one. It's delta ij, delta jk, delta kp, and delta pi. Okay. What is the value of this? See, delta ij is nothing but a matrix only. When I belongs to 1, 2, 3 and j belongs to 1, 2, 3. Typically in matrix we take always like by default 1, 2, 3 values because matrix are 3 by 3 by default. Okay, because stress is having a 9 components in which 3 are symmetrical. In total 6 different components are there. So we have a matrix of 3 by 3. That's why we took like all these notations for I and j value having 1 to 3. Okay. So now if I is equal to j, this is what? Delta 1, 1. This is 1. This is delta 1, 2, 0. Delta 1, 3, 0. Delta 2, 1, 0. Delta 2, 2, 1. 0, 0, 0, 1. Did you get this matrix? How I formed this matrix?
Yes, sir.
Okay. Why? Because delta ij is equal to 0 when I is not equal to j and is equal to 1 when I is equal to j. Okay. So this delta ij is nothing but a matrix. And one important point, the matrix multiplication can only happen
Sir, your audio is mute.
what?
Muted.
You are telling to me?
Yes, sir. Your audio.
How? What?
आवाज नहीं आ रही थी सर.
अच्छा अच्छा okay. See, this is one matrix which I'll say AB because I am using IJ, and this I will say CD. Okay, this matrix is of size A cross B, having A rows and B column, and the second matrix is having C rows and D column. So if you want to multiply these two matrices, what should be the case? The B should always be equal to C, then only you can do matrix multiplication. Like if this is a matrix of 3 cross 2, so this should be a matrix of 2 cross something, can NB value, but this 2 should be same. Then only you can multiply, because the rows of this matrix will be multiplying by the column of this matrix. You got the point? Whenever you are having a matrix multiplication, these two terms should be same. Okay?
Yes, sir.
So coming back to the question, we have delta ij, delta jk, delta kp, and delta pi. If we take in terms of pieces, this 2 will take as 1, this 2 will take as 1. Okay, multiplication. Okay, so see here, j and j are common.
Yes,
What it will become? It will become delta I k. Okay, what this will become? P and P are common. This will become ki. If we multiply this two matrix also, what will be the new matrix? It will be 3 cross 5 only, no? Okay.
3 cross 5. Yes,
Yeah.
sir.
Similarly here, j are common. It will omit out. What will we get? Delta I k.
Okay.
Here PP common. It will omit out. What will we get? Delta ki. Okay.
KI.
Now you are
Yes,
left
sir.
with these two things. Delta Ik and delta.
Delta K.
Now KK common.
Yes, sir.
What will you get?
And
Delta II. Now what is this
II.
matrix? This index? II.
Dummy.
Yeah, it's a dummy index. So what we have to do?
Yes, sir.
We have to sum it 3 times.
Yes.
So what is this? Delta 1 plus delta 2 plus delta 3.
3.
And what is the value of delta 1? Delta 2 1, delta 3 1. So what is the value? 3.
3. Oh.
So this is the answer.
Okay.
Got it?
Yes. Got it.
Similar type of question you will do in the assignment also and in the tutorial also. Okay, understood till now? So now we'll move ahead. Not having this base, I will move one step forward. Okay. Okay. Suppose we have a direction, Cartesian coordinates are like this. See, in this course, we are not using I, J, K. Instead of this, we'll be using E1, E2, E3. Okay. This 3 notation we'll be using. For A matrix, it will be like A11, I1 plus A12, I2. Like this will be
Sir,
using.
why cannot use IJK?
Because I'll tell you in the subsequent examples, because this IJK will come in another prospect. So not to confuse in two things, we are just separating out this indices. Okay.
Okay, sir.
Because and also it will be followed in a standard books also. You can see lecture also. Sir has given a detailed explanation of these things. Since I am having time limitation also, so I'll give you the brief thing, like what is like a summary of those things. If you want to see like each explanation point, you can see lectures of that thing. Okay. So this is E1, this is E2, this is E3. So what we said like that in the lecture, that vector can be presented by any form. Okay. Suppose someone is saying that I have noticed vector A1, A2, A3. One person is saying like this. And another person is saying that I have noticed the vector as A1 star, A2 star and A3 star. Both are correct. But how to relate these two things is what we have to understand. Okay. See, we are following this Cartesian system. Okay. So with this respect, we are getting this vectors for particular point. This point has a vector of A1 I1 plus A2 I2 plus A3 I3. Okay. Because we are following this Cartesian system. What if the other person will tell no, I won't follow this Cartesian system, I will follow this Cartesian system. E1 star, which is having some angle theta. E2 star and same as E3 star. Now he will say I will use this Cartesian system and I will get the position vector of this thing as AI star, A2 star and A3 star. He is also correct because he is following another Cartesian system. So in vector, if he is like representing these things, the main motive is that the magnitude and the direction of that position vector will always remain same. However, you are representing the vector in any way. So how to relate these two things? If you have related this thing and I have related this thing, how to relate in between these two? Because both are same. Okay, that's what we'll see. So suppose I said like A vector is equal to A1, I1. See, this dash is very important. This dash shows the direction vector. Okay. So please remember to put dash on these things. It's not like I am marking on my own. Everything has some meaning. A2, E2 plus A3, E3. Okay. So how we will write this cut short? AI, EI. Is this correct to write this thing? Because I is repeating twice.
Yes, sir.
And it's on the same side also.
Yes, sir.
So it's on a dummy index. Correct?
Yes, sir.
So now in future you will be seeing like this only. I won't be expanding this every time because you have to gain knowledge. That's why I'm expanding every time. But the real consequence is this only. Okay. So now you have to figure it out. So see, it's a dummy index. So the actual meaning of A vector is this only. Okay. So now we can say like that also that AI is nothing but the projection of A vector on EI. This is what we studied with dot product. That suppose this is EI, this is A. It's having some angle. So it's nothing but the projection at EI. Got this point?
Yes, sir.
So now this is equation 1, this is equation 2. So you know what is AI. So can you transform the equation? What will A become now? You put, instead of A, you put A dot EI. EI. Can you do this thing using 1 and 2?
Yes, yes, sir.
Okay. Now the other person comes, say, no, I won't say that it's a projection on EI. He will say it's a projection on EI star. Okay. So what we will write, like A vector he can represent as AI, EI star. Okay.
सर ये ऊपर आप एक्सचेंज कर दिए हैं
हाँ पे
ये जो पहला इक्वेशन है A इक्वल टू वेक्टर A इक्वल टू AI EI
हाँ सी ये जो था ये वेक्टर हम लोगों ने रिप्रेजेंट किया
हाँ वो डमी इंडेक्स
हाँ डमी इंडेक्स था इस तो ये एक्चुअल वे रिप्रेजेंट करने का वेक्टर को
ओके
अब हमने बोला कि जो AI है AI इज नथिंग बट द प्रोजेक्शन ऑफ वेक्टर A ऑन EI
हाँ
तो उसको हम ऐसे लिख सकते हैं AI को
ओके सर
तो हमने सेकंड इक्वेशन को 1 में पुट किया
ओके सर
ओके गॉट इट so up now second person will say that no I won't be using that Cartesian system. I'll be using some other Cartesian system having subtended angle theta. Okay, so we'll mark that as EI star. Okay, so same way we can write A vector as AI EI star. Similarly here now what A vector is, 1 second. So now here what is AI? Is nothing but the projection of vector A on EI star. Same thing as we did before.
Yes, sir.
So now if you put this thing here, what A vector will become? A dot EI star
Into A star.
into EI star. Now you will see why we are using E1, E2, E3 because we are using I here. So now if we are using I, E, J, E, K there, it will be like it will be getting like some noise like that thing. You're getting my point?
Yes, sir.
So that's what we have separated EI from this and that. Okay. So now this is the observation of one person and this is the observation of second person. Okay.
Yes, sir.
And both are correct. Now what we'll do next? So now moving ahead, we'll say that A dot EI from first this third equation. We'll put it as third equation. This will put it as fourth equation. I will change the colors. So will be equal to A dot with EJ star. EJ star. See, IJ I can differ, like EJ also I can write, because to separate out. This is not same. Okay. It's nothing like that. I only can be there. Okay.
Okay.
This depend upon us only. Okay. These both are same.
Yes.
Now we know that A is nothing but AI EI only.
Yes.
So how we'll do? So we'll put here.
Sir, 1 minute.
Your phone is ringing.
Okay, sir.
Shall I start?
Yes, sir.
Yeah. So now, see, for this person respect, we know that our A is nothing but AI EI also. Okay. So
Yes.
we put that AI EI in this equation. So what it will become? It will become AI EI dotted with EJ star EJ star. Okay. This is our A with respect to first person, having, if he is using the second person's coordinate axis, Cartesian axis. Okay.
Yes.
So now if I want now AB vector, now if I want AB star vector, some other vector we want, so what it will be? It's nothing but A projection on EB vector, EB star vector. If I want to calculate AB star vector, what is AB star vector now? So it's nothing but projection of A vector on EB star vector. Now what is A? It's nothing but AI, EI, EJ star. Here EJ star dotted with EB star. Are you confused, or like you are getting?
Sir, I'm little confused.
Yeah. Okay, I'll explain from first. Okay. See,
Yes, sir.
we have suppose one Cartesian system which we are following. It's like EI, E1, E2, E3. Okay.
Yes, sir.
Now one person is saying, okay, I will use the vector as 1 second.
A1 star, A2 star, A3 star.
I'll just do that thing also. Screen projection. 1 second. How to do that thing actually? So I'll say, like he will represent like that. Okay, I don't know that thing. Okay, so he will say like I will represent A vector as AI EI. Okay. So now second person comes. He said no, I will follow the another Cartesian system. He will say I will say A vector as EJ vector EI. Another person say A vector A as AJ EJ star. Okay. He say I will represent that this A vector as this thing in another Cartesian system. Okay.
Yes,
Now
sir.
how to relate these two things? Like both are correct. But if someone asks what is the coordinate of some vector A on that projection using that Cartesian system, how I will get to know the answer? Okay, I will solve one problem also to know you better understanding. Okay.
Yes, sir.
Now here what is AI? See, suppose you want to find any vector, like suppose you have example like A as I cap, I will not use I cap now onwards, 2E1 plus 3E2 plus 4E3, and someone says you have to calculate projection of A on EI. Okay, what is this? It's
Yes.
nothing but A dot EI, E1. Okay, so this is what AI means. AI is nothing but the projection of A on EI. Okay. Similarly, for other person, this AI becomes A dot EJ star. Okay.
Yes, sir.
Now we use mathematics, like we just substituted the value of AI into the A for both the cases, and we went up to here. Okay. So finally we got this thing. Okay.
Yes.
So if you see this equation, this 2 is nothing but a Kronecker delta. Delta JB. Okay. Because the dot product is there, so delta JB will come.
Yes.
Okay. Now this can be
Yes.
equal to 1 only when J is equal to B. Fine. Otherwise it's 0. Here this becomes Qij. Okay. So now whole expression of A vector becomes AB vector we are finding out. AB star is nothing but AI Qij delta JB, sorry. Okay. This you know, when J is equal to B only, delta JB is equal to 1. Okay.
Yes, sir.
These things you know now.
Yes.
So now it's nothing, these two terms. We are left with these two terms. If we assume that J is equal to B, okay,
Yes, sir.
you can only calculate A when it is equal to B only. Otherwise, all times it will be 0. Okay. So now it's nothing but this AIQJB we are left with is nothing but, one second, A vector transpose Q matrix. This Qij is nothing but, we calculated above, is EI dotted with EJ star. This EI is with respect to our coordinate system. EJ star is subjected to another coordinate system, which is subtended to angle theta. Okay. Okay. Now I will solve an example so that you can understand better. It's given a tutorial in assignment also, like same time of question has been asked. Okay. So suppose someone has said like that your example. Someone has said like, see, I have this basis function, this s ex plus ey by 2. I will represent new basis function as this. Whether, see, this e1, e2, e3, ex, ey, ez, these all are same. Okay. These are nothing but basis functions. Okay.
Yes, sir.
So second one will say, I will, the second person will say, I will define these functions like these things. Okay. Now you have one vector u. Okay. So how will you represent u in terms of new Cartesian system? You are getting my point? What is the component of u as per ey? Okay.
Yes, sir.
So are you there?
Yes, sir.
So suppose if I will ask you, see, you know the component of u in terms of ex, ey, ez. What is this? 1, 2, 3. In terms of ey, sorry, ex, ey, and ez. Okay. But what if someone asks you like, what is the component of u in terms of ex tilde, ey tilde, and ez tilde? You don't know.
No, sir.
Got it? So how will you know? See, first you have to find out this Qij. What is Qij here? Okay, Qij I told you earlier is nothing but Ei dot Ej star. Here it will be, in terms of question, it will be Ex dot Ex tilde. Okay, different coordination systems.
Yes, sir.
Okay, so when you will do this thing, or Ex dotted with Ey tilde and Ex dotted with Ej tilde. Similarly with all the things. Similarly with Ey dotted with Ex tilde, Ey dotted with Ey tilde, and Ey dotted with Ez tilde. Okay, so we'll make a matrix of Qij.
What do you mean by tilde?
This above sign, no?
Oh,
It's a notation.
okay.
See, we know
Okay,
this.
sir. Vector. Okay, sir.
So now if you do this thing, I'll form a matrix Qij. I'll write. It will be Ex dot Ex tilde, Ex dot Ey tilde, Ex dot Ez tilde, Ey dot Ex tilde, Ey dot Ey tilde, Ey dot Ez. This is Ez dot Ex, Ez dot Ey, and Ez dot. Till here you understood what is Qij?
Yes, sir.
So now you know Ex. What is the value of Ex tilde above? It is Ex plus Ey by 2.
2.
Okay. So now this dot product is nothing but Ij in terms of Ik, Jk, if you understand, is nothing but 1, 1 and 1, 2. So Ex dotted with Ex is 1 by 2. Plus Ex dotted with Ey will be 0. Confused?
Yes, sir.
See, Ex dotted with Ex by 2 plus
Yes, sir.
Ex dotted with Ey by 2. We can write like this.
Yes, sir.
So now same index. When dot product is there, Kronecker delta will come.
Okay, sir.
Here xy. When xx are there, it is same. Its value will be equal to
1.
here. Its value will be equal to
0.
because x or y are different.
Yes, sir. Yes, sir. Understand.
So this expression will become 1 by 2. Got it?
Yes, sir.
So first expression of Qij is 1 by 2.
1 by 2.
Similarly, we'll solve for other expressions also. What is Ex dotted with Ej, Ey tilde? Ex is Ex,
Yes.
Ey is minus Ey plus Ez by 2.
Okay.
As per question. Okay. Now what is the value?
Yes.
What is the value if you dot product this thing? Tell me.
Ui.
See, if you elaborate this thing, it will be minus Ey by 2
Yes, sir.
plus Ex dotted with Ez by 2.
PZ by 2. Yes.
Now if you see dot product is there, Kronecker delta will come.
Yes, sir. Delta actually.
It is there. See, both are different.
That is 0.
0.
Yes, sir.
So this is 0. Understood?
Yes, sir.
This thing. So similarly,
Yes,
we'll
sir.
fill all the things here. Okay. I'll fill all the things. I don't know the answer. I'll also do right now. 0. Ey with Ex. 1 by 2. You just try this at your home also, okay? If you don't get this matrix, no, just ping me in the next class, okay? I will explain you.
Okay, sir.
Okay, the lecture will be available in the YouTube also. The link will be shared with you. The notes also will be shared with the drive folder also. Okay, so solve by yourself also once these things. Then you will get clear understanding. So this is the matrix of Qij will get. You get it?
Yes, sir.
Now in above I said you that to find a new vector AB star is nothing but this A transpose Qij. So here if I want to find U X component, okay, is nothing but U vector transpose Qij. See here same expression is there. If I want to find Ux star, so it will be nothing but U vector transpose Qij. Got it?
Yes, sir.
So Qij we found out. U vector is given in the question. U vector is 1, 2, 3. Here it is given. See
Yes, sir.
in the question. So this transpose with the matrix. Transpose, you know what is transpose?
Yes, sir.
Rows become will column, column will become row. Okay,
Yes, sir.
so it will be 1, 2, 3. Multiply by 1 by 2, 0, 0. Okay, this is 3 cross.
सर इस लास्ट क्वेश्चन जो आप कर रहे हैं
हाँ।
दोबारा कहाँ देख सकता हूँ?
ये आप सेम अभी इसमें YouTube में इसका लिंक होगा इस वीडियो का एंड इसका स्प्रेडशीट भी शेयर होगा बाय मोस्टली बाय टुमारो मॉर्निंग यू कैन सी.
ओके, क्योंकि सर ये सेम टाइप का प्रॉब्लम असाइनमेंट में पूछा पड़ा.
हाँ, एक बार मैं फिर एक्सप्लेन कर दूंगा, कोई दिक्कत नहीं है. इसको है ना. See, this matrix is 1 cross 3, 1 row 3 columns. This is 3 cross 3.
3 cross 3 column.
So finally we will get matrix of 1 row 3 columns. This is nothing but Ux. Okay. This is nothing but U in new direction. Sorry to say. New as per the new that Cartesian system. Ex tilde, Ey tilde, and Ez tilde. Okay. This U vector. Okay.
Yes, sir.
So if you multiply this, you will get 3 numbers. This corresponds to Ex tilde. This corresponds to Ey tilde. This corresponds to Ez tilde. Okay.
Yes,
I'll explain you this thing again once more to have a better understanding. See, from here derivation will go. Okay. You can see the lecture for better understanding. That will give you a better understanding because there sir has took 1 hour for to explain only this thing. Okay.
Yes, sir.
So suppose we have a Cartesian system as per indicated by black. Okay, E1, E2, E3. We follow this Cartesian system. Okay. Now, for this Cartesian system, we have defined a vector A, which is equal to A1, E1 plus A2, E2 and AT, E3. Okay.
Yes.
Now, this vector we can write as AI, EI because I is a dummy index. It is more or less same. Okay. Now, suppose another person will come. He say, no, I will follow a new Cartesian system. E1 star, E2 star and E3 star, which is having an angle theta with the E1, E2, E3. Okay. He say I will represent a new vector as AJ and EI star. Okay. Now, in his respect, he is correct. In our respect, we are correct because we are following our own Cartesian system. But how to relate these two things? That is the question. So these all are the mathematical aspects we follow to get into the final picture. This. I'll use another color. This. So this is the vector of new Cartesian. Okay, and this is the old Cartesian as per the old reference Cartesian. Okay, so this is multiply this Qij matrix. This is nothing but a transformation matrix. This is known as transformation matrix. Okay.
Yes, sir.
So to relate the new Cartesian coordinate system with the old Cartesian coordinate system, we have to need a transformation matrix, which is known as Qij. Okay, this Qij is nothing but Ei dot Ej star. Okay. Now the example. In example, this Ex tilde, Ey tilde, and Ez tilde. These are the three new Cartesian system. We'll say. Okay.
Okay, sir.
This Ex tilde, Ey tilde, and Ez tilde.
And is it?
These three are new Cartesian coordinate system will follow. Okay, and this Ex, Ey, Ez are the old ones. Okay, this is I am just referring for your understanding. Okay, so now he is asking that he has given u with respect to old version. You can see this u is given with respect to old version. Ex, Ey, Ez he used in the question. So this is old version, and he is asking, tell me the u vector with respect to the new version.
Yes, sir.
Are you getting the point now?
Yes, sir. Yes, sir.
So now how to get new version of u vector with respect to the old version? So we need to calculate this transformation matrix.
Yes, sir.
So if we calculate this transformation matrix, this is the generic matrix formulation. Okay.
Yes, sir.
So now you have values of all the things. This is given, this is given. You can calculate the value. Form the matrix of Qij. You have formed the matrix. Now, when you have to find the new u, just put the old u. Okay, and put the Qij matrix. Whatever you will get the new u.
Okay, sir.
Got it?
In terms of Ux, Ex, Ey, and Ez.
Yeah.
Yes, sir.
Now get it? All things are clear?
Yes, sir.
If you have any other doubt, you can say.
No, sir. Clear.
This is what is covered in the week 1 lecture series. Okay.
Okay, sir.
So I have told you about the summary of all these things to get inside knowledge and to get a deeper knowledge, like what is actually mean, how it's going on, what is the derivation. I have explained you in a simpler version so that you can understand from a layman point of view. Okay.
Okay, okay, sir.
Okay. You can go through the lectures, go through this mind lecture also once more, solve the problems which I have solved in this lecture once more. Okay, we have solved like 2-3 problems for dummy and free index. We know how to use permutation symbol, how to use Kronecker delta, you know now. How to get u vector in new Cartesian system, you know now. Okay,
Yes.
just go all these things once by your own. Okay, if still you have some doubt, you can put in the forum, or you can directly ping me also. I can share my number also if you want.
Yes, sir. Please.
Okay. So I'll just put it in the chat.
Thank you, sir.
Yeah, this is my number. So you can ping me anytime also. Plus, I will be sharing these notes with the Google Drive link. I'll share you by latest by tomorrow morning. You will be getting it, and the YouTube link of this lecture. Okay, so you can refer once more.
Sir, it's your WhatsApp number.
Yeah. I hope you have understood something. Like I have explained you something better. Like
Yes, sir. Yes, sir.
you can give your feedback also. Like I am always open for feedback.
Okay.
Okay.
Yes, sir.
Okay. Now we'll leave. Hope we'll meet you again to next week. Okay, with the new week.
Yes.
Okay. Thank you, Anna.
Yes, sir. Yes. Thank you, sir.